So in determining the exact rate of maturity, which is the same thing as the internal rate of returns, I am going to be taking some steps. First is to calculate calculate MPV. I'll be needing two MPV. One must be positive, while the other one must be negative. I'm saying that to calculate the yield to maturity, I will be needing two. I will be calculating the MPV from our example where we have number of years to be 5, rate of interest 10%, current price 850, yield to maturity unknown. So I will use this information to calculate the MPV of this project using what we call the trial and error method. In that trial and error method, I will need one MPV that must be positive, and I will need another MPV that must be negative. So what I will do to determine those two MPVs is what is called the trial and error method. When I've gotten the two MPVs, one negative and one positive, I will then do what is called interpolation. That by doing that interpolation, I will be able to arrive at my approximate yield to maturity. So in calculating the MPV, I will take a guess. First of all, my rate of interest, as usual, 10% of 1,000, which is 100 naira. So now that I know my rate of the amount of interest per year, 0, 1, 2, 3, 4, 5. Cash flow, discount factor at present value. So every year the borrower will pay 100 naira as interest. Then at the end of the 5th year, he will also pay the 1,000. So to determine the MPV, I will take a guess. That's why it's called trial and error. I will take a guess. And how do I take the guess? What figure? I'll take a guess of a discount factor that I will use to discount this stream of income to get an MPV, maybe positive or negative. When I get any MPV, then I will now know what to do to get the second MPV. So in this case, I will be guessing. I will not go too far to take my guess. I will be guessing from here. I will use this exact information I was given to take my guess. So if I take a guess of 10%, as my discount factor, in year 1, I will have my discount factor at 10% to be 0.9091, year 2, 0.8264, 0.7513, 0.6830, 0.6209, 1.0. So for year 0, I will put what the current market price, because that is the current what I have here. So if I multiply these two, this should give me 850 negative, because I'm spending the money immediately. This will give me 90.91, 82.64, 75.13, 68.30, 62.09, and 620.9. So to get my MPV, what I do is I add up all these values. whatever I have, I subtract 850 from it. So I add up all this value and subtract 850 from whatever I have. So I have 90.91 plus 82.64 plus 75.13 plus 68.30 plus 62.09 plus 620.9. That gives me 999.97 if I'm correct. Then I subtract 850 from it. That gives me 149.97. So I have a positive NPV now. And I said that I need two NPVs. One must be positive and the other must be negative. Now I have calculated, I have gotten a positive NPV. So what I will do is that I will calculate again. I will extend this table and use a discount factor that is higher than this 10%. I will continue, that's the trial and error. I will continue to use discount factor that is higher than, I will continue to raise the discount factor until I get NPV that is negative. Had it been that I got a negative NPV at first, what I do is I will continue to reduce the discount factor until I get a positive NPV. But in this case, with 10%, I got a positive NPV. So what I do is to raise it maybe by 5% to 15%. And see if by using 15%, I am going to get a negative NPV. So by 15%, I have 0.86, 96, 0.7561, 0.6575, 0.5716, 0.4972, and 0.4972 again. This is 1.0. So if I multiply this again, I get my 850. If I multiply this and 100, it gives me 86.96. This gives me 75.61. This gives me 65.75, 57.16, 49.72, and 497.2. I hope you understand that I was multiplying these two. I was multiplying these two columns. So now I will add all this again. Whatever I get, I subtract 850 from it. It's 86.96 plus 75.61 plus 65.75 plus 57.16 plus 49.72 plus 497.2. So that gives me 832.4. So if I subtract 850, from my answer, I will have 17.6 negative. So now I have been able to get two NPVs, one positive and the other one negative. So having gotten these two NPVs, one positive and one negative, I can now go ahead and interpolate. Having gotten these two NPVs, one positive and one negative, I can now go ahead and interpolate. So at 10%, at discount factor at 10%, my NPV NPV was 149.97, and then a discount factor of 15%, my NPV was 17.6 negative. Those are the information I need. So to interpolate now, I will have yield to maturity equals to the discount factor that gave me the positive NPV plus that positive NPV divided by the two NPVs added together. NPV, okay, I can call this NPV1, NPV2. The two NPVs added together, multiplied by the discount factor that gave me the negative NPV minus discount factor that gave me positive NPV. Everything in percentage. Now at this point, I am going to input the figures. So the discount factor that gave me positive NPV is 10%, which I can write as 0.10, plus that positive NPV is 149.97 divided by 149.97 plus 17.6 multiplied by the discount factor that gave me negative NPV 0.15 minus 0.10. Everything, my answer must be in percentage. So I can now have 0.10 plus 149.97 divided by, if I add these two together, (149.97) plus 17.6, that gives me 167.57. Multiplied by, if I subtract this, I have 0.05 in percentage. So at this point I'll be very careful, because this is asking me to do three things. To add, this one to divide, and this to multiply. How do I then know which of these three things I'm going to do first? I'll just follow the simple rule of BODMAS. Brackets off. I can remove the bracket just so I will not confuse myself. Can take this out, off, not there. Division first, that's what I do first. So I divide first. So I come to divide first, following the BODMAS rule. You must be careful here, otherwise once you don't do the first thing first, you cannot arrive at the correct answer. So I do the first thing, which is division. 149.97 divided by 167.57. That gives me an answer, which I will leave on my calculator. I have done the division, I'm leaving it on my calculator. Then the next thing I am doing according to the BODMAS is multiplication. So my answer here, I have done the division, then the next thing is to multiply. My answer now, I multiply by this times 0.05. I have done the multiplication now. Then the next thing is addition. I can then come and add, plus. Now that I've added, I've done the 3, I've now gotten my answer to be 0.1447 in percentage. So if I multiply by 100, I will have 14.47. So this is the exact yield or return that will make exact yield or returns that will make the project to be worthwhile. That's the exact yield or returns that will make the project to be worthwhile. If you look at this figure that we got and the approximate yield, you will see that they are close. The approximate yield is almost the exact yield, but it's not the same. So the approximate yield is, if you don't have time, it's used if you don't have time. You need an idea around what the information should be. The approximate yield gives you an idea that is almost the perfect thing that you need. Again, call provision is another item that can be found on the indenture that is worth looking at. A call provision gives the lender the right to call back to ask for the repayment of the loan or the bond before maturity. I take that again, that the call provision gives the lender the right to recall the bond, to ask that the bond be repaid before maturity. There are three types of call provisions that may be found on the indenture. The first is the non-callable provision. This simply means that the bond cannot be recalled at any time by the lender, irrespective. The second type is the freely callable bond. The freely callable provision gives the right to the lender to call back the bond anytime before maturity. The only thing that is required of the lender is to give prior notice of like 30 days or 60 days to the borrower to repay. And the third one is called the deferred callable bonds, or the deferred call provisions, which gives the lender the right to recall the bond, but not until after a specified period of time. For example, it may be agreed that the loan can be recalled back at any time, but for that the first 2 years or that the first 3 years, the loan will be uncallable. We may then wonder, under which condition will a lender want to recall a bond? A lender will like to, or will be moved, or will want to recall a bond when the bond is selling at a premium. When the bond is selling at a premium, that is under the circumstances under which the lender may want to recall the bond. In which case, we will no longer be calculating the yield to maturity, we will be calculating the yield to call. Because the bond will no longer reach maturity, the bond will terminate at the date when the lender decides to call it. So therefore, we look at an example. Assuming we have a 12% 1,000 naira bond with a maturity of 5 years, and which is currently selling at 950, but the lender now realizes that this bond is selling now at 1,150 premium, and then decides to call back the bond after 3 years. To call, 3 years. What then will be the yield to call? Or the approximate yield to call? The approximate yield to call will be R plus price to call minus current market price, number of years to call, divided by 1/2 of the price to call plus price of debt into. So that the R, which is the interest, is 12% of 1,000, which gives us 120. So therefore, the approximate yield to call becomes 120 plus 1,150 minus 950 into 1/3 divided by 1,150 plus 950 into 1/2. So what we have from here will be that the approximate yield to call equals to 120 plus 200 to 1/3 divided by 2,100 into 1/2. That gives us 120 plus 66.67 divided by 1,025. So from here we have, if we add these two, we have 186.67 divided by 1025. That will give us, if we divide it, that should give us 18.21. Now multiply by 100 to convert to percentage, that should give us 18.21% as the approximate yield to call. The last item we will be discussing is duration. Duration is the weighted average of the lifespan of a bond, where the weight is the timing. Let's assume that we have a 12% 1,000 naira bond with a duration of 5 years and the yield to maturity of 15% with a current market price of 950. The question now is, what is the duration of the bond? The duration, like I said, is the weighted average of the lifespan of the bond, where the weight is calculated as the timing of the bond. So in this case, our interest for, as usual, is 12% of 1,000, which is 120, and then duration is calculated as R all over 1 plus yield to maturity at time t, everything multiplied by t, plus maturity value at time n, all over 1 plus yield to maturity at time n, everything multiplied by n, divided by current market price. Now, let all this formula not deceive us. What are we supposed to do? We have here 1, 2, 3, 4, 5. Cash flow 120, 120, 120, 120, 120. Weight. This weight is multiplication of this times this is 120. 2 times 120 is 240. 3 times 120 is 360. 4 times 120 is 480. 5 times 120 is 600. And then here 5, where the 1,000 will be repeat. 5 times 1,000 is 5,000. We have the discount factor at, or the yield to maturity at 15%, and then the present value. I have now used my calculator to determine the yield to maturity, the discount factor at 15%. So what I'm going to do next is to multiply these two columns. Multiply these two columns. This times this equals to this times this times equals to equal. So I have 120 multiplied by 0.8696. That gives me 104.35. So I have 240 multiplied by 0.7561. That gives me 181.46. I have 360 multiplied by 0.6575. Gives me 236.70. So 480 multiplied by 0.5718, 274.46, and I have 600 multiplied by 0.4972, 298.32, and then I have 5,000 multiplied by 0.4972, this will be 2,486. So I sum everything together, 298.32 plus 146 plus 236.70 plus 181.46 plus 104.35. So when I sum everything together, I have 3581.29. So therefore, my duration then becomes 3581.29 divided by 950. That gives me 3.77 in years. That's approximately 4 years. That means that my duration is approximately 4 years. So what this implies is that as a wise investor, I will not enter into this bargain except the maturity of the bond will not exceed 4 years. But instead of these 5 years, it will pay me as a lender if the duration of the bond does not exceed 4 years. Thank you so much for watching, and stay blessed as always. Best regards.